Today we're going to do 6.6 rational exponents. What I want you to do is grab your calculator, and it can be a graphing calculator, it can be a regular calculator, it just needs to be a scientific one. And I want you to type in 16, and then hit the caret button, and then put 1/2. When you hit equal, it tells you the answer is 4. 16 to the 1/2 power is the same thing as taking the square root of 16. If you have one of the older graphing calculators and don't have a fraction sign, then just hit 1 divided by 2 as your exponent. So raising something to the 1/2 power is the same thing as taking the square root of 6. So what you need to know is the notation that b to the 1/nth power is the same thing as the nth root of b. And the same thing is as b to the xy is equal to the y root of b to the x. So these are the two things that you need to have memorized. So let's do some examples of these. The first one, x to the 1/6. That's the same thing as the 6th root of x. And if you want to work ahead on these, that's fine. Or if you want to pause it and do one and then unpause it to make sure you have the right answer, that's fine as well. The next one, the 8th root of c is the same thing as c to the 1/8 power. Most of your homework tonight is based on this stuff here. The cube root of c to the -5 is equal to c to the -5th over 3. A to the 1/5 is the same thing as the 5th root of a. And then d to the 7/4 is the same thing as the 4th root of d to the 7th. The next one, 81 to the -1/4. Well, first of all, we're going to try it in your calculator, and I know that's how you'll do it most of the time is put it in your calculator and get the answer, but I need you to know how it works in your calculator as well. So you can type in 81 raised to the -1/4 power, and it tells you 0.3 repeating, which is 1/3. So make sure you turn that back to a fraction. All of your answers today need to be written in fraction form. So this is the same thing if you remember that if you have a negative exponent, it goes to the denominator. So 81 to the 1/4 power. 81 to the 1/4 power is the same thing as the 4th root of 81. And if you look at in your 4th root column, the 4th root of 81 is 3. So your answer is 1/3. The next one, we're going to put one in between here. 216 to the 2/3 power. Again, I would just type that in my calculator if this was your homework assignment, which is our answer would be 36. What that is the cube root of 216 squared, which means that's the cube root of 46,656. And if you type that into your calculator, it tells you it's 36. The next one, the negative exponent moves it to the denominator. So we have 1 over -3,125 to the 1/5 power. And so -3,125 raised to the 1/5 power is -5. So your answer is -1/5 or 1 over -5. The next one, 256 to the 3/8. So let's just type that one in our calculator. 256 raised to the 3/8 power. You should get 8. You can also rewrite that one if we wanted to as 8 to the 256 to the 3rd power. Okay, let's drop it down and do some variables here. We have a to the 2/7 times a to the 4/7. When you're working with exponents of variables, when you're multiplying their variables together, if you remember, you add their exponents. So the answer to this would be a to the 6/7. The one on the denominator, the next one, b to the -5/6 is the same thing as 1 over b to the +5/6, which what this means is you have 1 over the 6th root of b to the 5th. Which our problem is we can't have a radical on the denominator. So what we're going to do here, instead of multiplying the 6th root or 6 times there, we're going to look at this and we're going to say, well, what will make this a whole number? What will make this 1? Well, if I multiply it by b to the 1/6, because remember, if you're multiplying the bases, you're adding their exponents, this becomes b to the 1/6 on top, and on your denominator, it just becomes b. And so that would be your answer because you got your radical off the denominator. The next one, p to the 1/4 times p to the 9/4. Same thing, you're multiplying the bases, so you need to add your exponents. So this would be p to the 10/4, and then you would just reduce, so p to the 5/2. The next one, r to the negative 4/5. It's negative, so you have to move it to the denominator. So 1 over positive 4/5. But now we have a radical on the denominator, so we want to multiply by something that'll get this to be a whole number. So r to the 1/5. So you have r to the 1/5 divided by r. On the next one, we cannot just divide the 4th root of 27 divided by the square root of 3 because they don't have the same radical. But we can rewrite this as 27 to the 1/4 power and 3 to the 1/2 power. Now we have to simplify 27. So for an example, if you would simplify 16, you could write 16 as 2 to the 4th power. You can rewrite 4 as 2 squared. 27 we can rewrite as 3 cubed. Your goal is to have the bases be the same. The bases being the 3 here. You want the numerator to have the same base. And we have a power to a power rule. So we have 3 to the 3/4 divided by 3 to the 1/2. Well, now that they have the same bases, you can subtract them. You have 3 to the 3/4 divided by 3 to the 1/2. You subtract their exponents, and you get 3 to the 1/4. There we go. The next one, the cube root of 64z to the 6th. We can rewrite that as 64 to the 1/3 and z to the 6/3. 64 to the 1/3 is 4 z squared. The next one, if we have 4, the 4th root of 32 over the cube root of 2, we can rewrite that as 2 to the 1/3, 32 to the 1/4. We need to rewrite the base here. 32 can be rewritten as 3 to the 5th, raised to the 1/4. So that gives us 2 to the 5/4 divided by 2 to the 1/3. They have the same base, so you can subtract their exponents. 5/4 minus 1/3 is 2 to the 11/12. Okay, so we have 2 problems left to finish. These look a little bit scary and difficult, but you guys have been doing the same thing in other problems. So we have x to the 1/2 minus 2 over 3x to the 1/2 plus 2. So what's wrong with this problem is that this x to the 1/2 is a square root of x, so you can't have a radical on the denominator. So you guys are going to have to multiply the top and bottom by the conjugate of the denominator. So 3x to the 1/2 minus 2, and if we do it to the denominator, we have to do it to the numerator. So you have to FOIL the top. So x to the 1/2 times 3x to the 1/2 is 3x. X to the 1/2 times negative 2 is negative 2 x to the 1/2. Negative 2 times 3x to the 1/2 is negative 6 x to the 1/2. Then you have -2 times -2, which is +4. Our denominator, remember they are conjugate, so you only have to multiply the first and the last. So 3x to the 1/2 times 3x to the 1/2 is 9x. +2 times -2 is -4. The only thing you have left to do is on the numerator to combine your like terms. 3x minus 8x to the 1/2 plus 4 all over 9x minus 4. And that would be your answer. So what I want you to do on the next problem is I'm going to write it down, but then I want you to pause the video, solve the problem, and then check your answer. So we have y to the 1/2 plus 2 divided by y to the 1/2 minus 2. So here's where I want you to pause it, work the problem, and then when everyone's finished, you can check your work. So now that you're finished working the problem, hopefully, we need to multiply the top and bottom by the conjugate of the denominator. So on the numerator you FOILed, so you had y to the 1/2 times y to the 1/2 is y. You had plus 2y to the 1/2 plus 2y to the 1/2 plus 4. The denominators were conjugate, so you multiplied the first and last. So you got y minus 4. Combine like terms on the numerator and you get y plus 4y to the 1/2 plus 4 over y minus 4. And that would be your final answer.